Thank you. First, I want to acknowledge the organizing committee to allowing me to present this work, because I am not dealing with soil classification really. I work with paleosols. Unfortunately, classification of paleosols is something very complicated because the paleosols lack of diagnostic features or horizons. And this is a pity because soil classification and paleopedology have different ways. They don't merge. But this year in Glasgow, we will have a common session, soil classification and paleopedology. So maybe this is a way that we can find a common way to see the classification of paleosols. But today I will follow the road of the previous presenters, talking about degradation of volcanic soils. And I will start with this map. This is Mexico City in pre-Hispanic time, more or less 2,000 years ago. And we have in the center of the map the occurrence of the lacustrine bodies surrounded by volcanic structures. The southern part of these volcanic structures are Pleistocene and Holocene, while in the northern part we have older volcanic materials. In the map in the right, we can see Mexico City today. And we have two different areas. In the northern part, marked with this reddish color, we can see the urbanization, and then all the soils are sealed by the constructions. In the southern part, we have the conservation zone where volcanic soils occur, and they are still present in this area. This area, conservation zone, has been very attractive for agriculture, not only today, but in the past, because in this area, agroecological systems occurred. And in this area, the famous chinampas, that is technosols constructed by pre-Hispanic cultures, allowed people to growing crops during the whole year. During the colony, we have a big transformation of the landscape because of the moving from the chinampas to the hill slopes of the volcanic structures. And the Spanish conquerors brought to Mexico the cattle, and then the rising of these cattle provoked extensive erosion in the area. Now let's see what soils we have in this area. You can see here, this is the conservation zone, and we have mainly andosols, we have phaeozems, leptosols, histosols, and glacisols that correspond to the chinampa areas and the lacustrine areas nowadays completely or more or less completely dried. Let's have a look to this area in the square. We have, once again, the andosols together with the phaeozems and the leptosols. And I want to associate this kind of soils with the parent material, that is the volcanic ash. So we have these two maps showing the main volcanic structures. We have one in the north, the Teutli volcano. We have the Tlaloc volcano. This is a big stratovolcano with many eruptions in the area. Lava flows going through the north. And Popocatépetl volcano is not shown in this map. It is located a little bit more to the east. And in this photo, we can see an area, sorry, the pointer is not well, but let me see if, yeah, here we have two more volcanic structures. This is the Ayaquemetl volcano and the Two Cerros volcano. So what are the questions that we put regarding soil classification? Andosols are young soils. And several works have documented the transition from andosols to other soils in 10,000 years. In Mexico, we have observed these transitions in many places in the Trans-Mexican volcanic belt. We have luvisols in volcanic materials older than 10,000 years. But I'm sorry, I forgot to say about the ages of the volcanic materials. You have here the Teutli volcano has an eruption 36,000 years ago. We have Popocatépetl volcano with two big eruptions in 17,000 years BP, and another one 6,000 years. And the rest of the volcanoes have eruptions around 14 to 6,000 years. So with this perspective, we expect to have more luvisols in the area, but we have no luvisols. Well, what is the reason of this? And the feocems that we have found in this area are because of the land degradation. And another thing is that the area has been cultivated for a long, long time. The anthrosols that we have observed here are all the cultivated soils are anthrosols or not. I have to say that we didn't analyze all the qualifiers or all the diagnostic features, and then our classification is mainly based on morphology and some analytical properties. So this is the area that we study, the Teutli volcano located here, and the Ayaquemetl volcano that is located more to the south. Here, we have several profiles, but I will show only three, sorry, two in the Ayaquemetl volcano and one in the Teutli volcano. The idea is that you see the kind of materials we have, polygenetic soils, paleosols, and eroded, degraded soils. So this is the first profile, is located in the Ayaquemetl volcano, in more or less at the top of the volcano. It is still under forest. And you can see here that this is polygenetic soils with at least 3 cycles of soil formation. We identified the Tutti Frutti pomis. This is from the Popocatépetl volcano in the bottom of the profile that is 17,000 years BP. The other materials, we don't know the age. Let's see some of the properties of these soils. They have a positive reaction to this phenolphthalein test. So maybe this is a proof of andic properties. They are very silty. We have a low bulk density in all the materials, and the pH is more or less neutral, and the total organic carbon in the top is around 2.2%. Now let's see some images of the thin sections. Micromorphology is one of our tools to evaluate several aspects of our work. But in this case, I want to use to show the nice granular spongy structure typical of andosols in this area. But besides this, we can see some tephric materials. For instance, we have this pyroxene in the center of the photo. This is an olivine, sorry. this olivine that is very fresh. But together with this fresh material, we have very strongly weathered minerals. So this together in one horizon. Besides this, we found charcoal. We have these rounded fragments in the center of the photo, and that if we see with more amplification, we can see that it is the rest of a soil that was eroded and incorporated in the soil. So we have some colluvic material inside this polygenetic soil. So what about the classification? We can say that this is an andosol. Sorry, because of these qualifiers, maybe they don't fit at all the correct classification, but I try to do this exercise that we have these colluvic and siltic properties. Okay, this is what we expected in the area. We don't have any lubic feature because the material is reworked because of the volcanic activity as well as by colluvial processes. And then let's see the second profile. It is located 1 kilometer down slope of the Ayakemet, and this is an agriculture area. And here we have the complete profile. It is very similar to the previous one with these 3 cycles of soil formation. But the main difference that we have observed here in the modern soil is that we don't have this positive reaction to the test of the phenolphthalein, and the amount of organic carbon is a little bit lower. Another interesting thing is that the farmers built terraces and they removed the topsoil and they left the Paleosol, these 2 ABW horizon, in the top of the terrace. And then now the Paleosol is in this terrace and they are cultivating in this material. So we can expect some changes in the soil classification because of the use of this Paleosol. Let's see some of the thin sections that we have done. And here the structure is not similar to the Ayakemet volcano. The material is more loosey, more porous. We have less dark material in the ground mass. But we have also these materials, surrounded materials that are from soils, reworked soils. So once again, we have here this colluvial material incorporated in the soil. Additionally, we observe charcoal and these areas with like crust in the photograph of the left side, like crust maybe of the former soil, of a former soil. What about the classification? In this case, I don't rely. This is an andosol. Maybe this is a phaeocene. This is a question for you. And the paleosol probably is a cambisol. I don't know. But what it's interesting here is that this new this paleosol is now incorporated to new pedogenesis. And last profile, it is located in the Teutri volcano, in the foot slope here. And here we have the most degraded soil. You can see here the area. In this terrace, the farmers have been cultivated for more than 60 years. And what we observe is a lack of organic matter in the top, at least lower, much lower than in the previous site. The bulk density is higher. And additionally, we have here the Teutli ashes that date to 36,000 years. But it is an entisol, regosol. I'm sorry, I am now mixing the classification. But let's see what about the structure. We have a very loosey structure. The material is somehow dispersed in the ground mass. We have this tephric material once again, and but we still observe the rest of the granular structure of the andosol phase. Very degraded, but it is still present. So we decide to classify this soil as an anthrosol because it is cultivated for a long, long time. And the question is that if we have all the soils in this area of the Teutli volcano, the cultivated soils in the Teutli volcano, in this way of classification. We don't know. We are in progress with this investigation. This is the general conclusions. We have these volcanic soils that in the natural condition are andosols. We don't have luvic features because the ages of the volcanic materials are younger, and we have this colluvium that is incorporated in the soil, and then the zero time restart the process. Okay, this is the end. Thank you.
Thanks, Elizabeth. Okay, the presentation is open for discussion. How's about? Okay, please go ahead. You say your name, I forgot it.
Alberto.
Voy a hablar y tú me traduces.
Okay.
Realmente los impactos de la actividad humana en el cambio de las propiedades de los suelos es muy importante hoy en día en la clasificación de suelos.
The anthropogenic impacts in the soil classification is a really important thing.
En estos tres trabajos se ve cambios de tipos de suelo, grupos de suelo, por influencia de la erosión o del cultivo.
In the past three works, we have seen the influence. In the past three works, we have seen the influence in the change of the group's classification for the anthropogenic activity.
Yo pienso, por lo menos lo tenemos en nuestra clasificación de Cuba en la última versión, que hay que poner, en estos casos nosotros ponemos como subtipos agrogénicos o erogénicos con su diagnóstico.
In the case of Cuba, in the Cuban classification, we name it erogenic or erogenic or anthropogenic.
En unidades de la clasificación se pone la intensidad, mediana erosión, fuerte erosión, etc.
And we also classify the intensity of the erosion, high erosionated, medium erosionated, low erosionated.
Cuando el suelo está completamente erosionado, nosotros le llamamos aerosol de tal tipo de suelo.
When the erosion is really bad, we call it erosion of some of
Erodosol. They name the soil erodosol.
erodosol.
¿Por qué? Porque eso es muy importante en los mapas.
Because that is a really important thing in the maps.
A la vez que se dice aerosol, se sabe que ya perdió completamente el horizonte A y el horizonte B.
When we call the aerosol the layer A and the organic layer, it's gone.
Ponemos de qué tipo de suelo.
And we also associate
Aerosol de suelo alítico, aerosol de suelo pardocialítico, etc.
we also associate the erosion to that specific type of soil.
Pienso que eso es importante tenerlo en cuenta para reflejar realmente estos procesos de transformación que ocurren en los suelos por la acción antropogénica.
So I consider that type of classification, and to be specific, it's really important for the classification. Thank you very much.
Yes, thank you, Alberto, for these comments, because we observe that agriculture, we eat from the soil. This is something that maybe we can stop completely. But the bad practices during a long term go to this kind of degraded soils, and now we have to invest money to improve. For instance, in this project, what we are intending to do is to improve structure and the organic matter content using different improvers of soil.
Peter.
Okay, so thank you for your information about the results of management. But for sure, long-term agricultural cultivation does not change any soil into an anthrosol. Only specific measures do that. So the soil you showed for sure is not a plagic anthrosol. You must read the definition of the plagic horizon and the criteria and apply them. And one of the criteria is occurs in locally raised surfaces. Also for terric, for erratic, locally raised surfaces. For others, certain amendments or certain cultivation measures. Also the undersols. You call them a tephric undersol, but every undersol has at least one of the following qualifiers: vitric, aluandic, and silandic. Vitric properties or andic properties with silandic criteria and andic properties with aluandic criteria. At least one of them exists, sometimes two or even three. So these soils, as you classified them, they cannot exist.
Okay, thank you. Thank you for the input. This is very important. I try to do following the guide, of course, and following what the qualifiers were, but I failed. Sorry.
May I add to this statement that you say that the undersoils degraded. Now, degradation is normally that land use possibilities reduce. Now, in this case, I think it's the other way around. Through this anthropogenic activities, the land use possibilities improve. So I would say they change to in the direction to undersoils. It's not a degradation, really, I would say.
Maybe.
Maybe.
Yes, because finally we don't have the same amount and maybe quality of the organic matter. Because the cultivation changes this kind of organic matter. Then maybe this is a degradation process, maybe this is only a pedogenetic change in the trend of the pedogenesis, I mean.
Yeah, thank you. Now Cesare.
Yes, thank you. I agree with you that erosion, truncation of soil profile is a kind of degradation. Development of, as they were called, erodosols, yes? Our calcisols, Polish calcisols, commonly are already calcic erodosols, we can say. So there are false calcisols, in fact, yes? But what I wanted to say, accumulation of material which produces thicker A horizon, rich soil, as you shown us, the phaeosems, for example, can we say it is degradation? It is rather aggradation. It is production, yes, erosion, okay, has two sides, degradation and aggradation, yes? For if we analyze it on a slope, there are two faces of the same phenomena, yes? So for us, it is quite commonly observed also in Poland, that in hilly areas, what was shown by Marcin, for example, erosion produces as eroded soils in the upper parts of slopes, yes, and aggraded, thickened, upbuilt, we can use various words, soils, quite often phaeosems in lower positions. So there was even idea that the percentage of black soils in post-glacial areas may be used as an index of spatial transformation or degradation of landscape due to intense land use and erosion, but the black earths or your phozems were marks of aggradation, not only degradation. Thank you very much.
But in this case, we don't have any aggradation of soil organic matter. On the contrary, we have losses of organic matter. We have no manures are fertilizers, so these soils are not aggraded. They are degraded in organic matter. And another thing is important is that we were looking for the areas where this organic matter can be located because of the erosional process move from the top to the lower positions. But in the area, thousands of kilograms are taken to sell in the markets as air for the ponds. So people can go to the market and buy this earth and put in the gardens or in the ponds at home. So this is also another very important issue that we have to take into account. We have more degradation than aggradation. So.
Okay, we come to the end.
Yes, thank you.
No,
We have one more. Thank you. Sorry.
Thank you so much, Professor Elizabeth. And my question is related to paleosols. You talked about them in your presentation. And I think sometimes that the paleosols are like in the limbo of names because rocks have names, soils have names. Even we are in a Congress of names of the soils. And you as paleopathologist, you think that paleosols need names?
Of course, there were attempts to do a classification of paleosols. There are several works, but all the time we face the problem that we have no diagnostic features that can follow in a more homogeneous way. As Sergey told in the morning after the presentation of Curtis, why we have to do different way of classify more or less the same. So in a paleosol, you can follow the diagnostic features you are watching, but the way that we classify is following what we know, the modern soils. So in this case, it's very difficult to find a real name for the soil. So I think that the paleopathology community just need a classification, but I think that we more or less feel comfortable with what we have. Thank you. Okay. That's all now.
Thank you. Well, I must say my first attempt to go into soil science was on paleosols. And what I want and what we should want, we want to understand the soil formation and the processes. And so the classification is not so important in paleosols, but you need more fantasy to classify them than the surface soils. Yeah?
Yes, okay. I think we apply geofiction or soil fiction.
Okay.
Thank you.
Good,
Thank
you do it. Okay, I want to thank all the contributors so far and all the people contributing to the lively discussion. We have now the coffee break.